the big key here is if it's a monomial, what do we multiply by? What do we multiply by here to rationalize? Just root 3. If it's a monomial, you just multiply by root 3 over root 3. If it's a binomial, like in B, what do you multiply by? The conjugate, 3 plus 2 root 5 over 3 plus 2 root 5. Now, I'm not going to simplify those out, but we get the idea. We have to rationalize imaginaries in the denominator as well, because I is the same thing as a square root, isn't it? Right? I is the same thing as the square root of what, Connor? Negative 1. So you cannot leave I in a denominator. So in A and B, I is a part of a monomial or a binomial? Monomial. So if it's a part of a monomial, just multiply by I over itself. So our numerator is going to be 6I. What's negative 4I times I? Negative 4I squared. And the I squared is going to change that denominator to a positive 4. Right? I squared being negative 1 changes that denominator to a 4. And what about 6 over 4? Side note, it reduces to 3 over 2, which we probably should have done from the start. 6 over 4 reduces to 3 over 2. Okay? In B, the I in the denominator is part of a monomial. I realize there's a binomial on top, but I don't care about that. It's all about the denominator. So if it's got an I as a monomial, you just multiply by I over itself. Now, because of the binomial in the numerator, I do need to remember to do what? Distribute, yep. So that's 6I plus 8I squared over 9I squared. And then 8I squared changes to what, Cameron? 6I minus 8, very good. And the denominator turns to what, Maddie? Negative 9. Perfect. Yes. You can if you want. If it was a multiple choice, it may be written like, it may be negative 6I plus 8 over a positive 9. That would be an equivalent. Do you like that better? It might be 8. Now they might take this and make it 8 minus 6I over 9. Is that better? I don't know if you're not supposed to, but you are right that they do typically take them out. It's not improper. So if it was an open response and you left it, fine. If it was a multiple choice, you do need to understand little adjustments and how all three of these are the same exact thing. Does that make sense? Typically they will, yeah. Not always though. Sometimes they do weird things. Like even in one of the multiple choices the other day, they had a radical 18 in the answer, and they didn't break that down. But typically they should. Okay, so C and D are different now because we have a binomial. And so if we have a binomial in our denominator with a radical, which we do, we multiply by its conjugate. Now, we just spent a lot of time talking about how when you multiply complex conjugates in your denominator here, you always get a what kind of number? Real number. We just talked about that. That was like the John's explanation one that we looked at on the homework. So we should expect the denominator to become a real number. Whatever happens to the numerator just happens. So distribute your 4, you get negative 12 plus 24I. In your denominator, the beauty of conjugates is that your outer and your inner products will cancel. use that to your benefit and don't go through all of that. Just do your first times your first, which is 9, and your last times your last, which is negative 36i squared. And because I squared is negative 1, Aiden, what's going to happen to my denominator? 9 plus 36, which is 45. Very good. What do you notice about all of these numbers? What's their common factor? 3. 3 goes into all of those, so we can reduce everything here by 3. And that would be the best, most simplified answer. Okay? And D, what am I going to multiply by here? Oh, McKenna? Very good. Over itself, right? Can someone remind me why we multiply by this thing over itself? Nate? You're basically multiplying by 1. We're going to change the appearance, but we are not changing the value because we're multiplying by 1. Nice job. Sometimes we kind of forget why we're doing it over itself. So on our numerator and on our denominator, we have to FOIL. So take a minute to do that, and you can look up it to the board to check your work. I don't know about you guys, but in my denominator, again, I skipped the outer and the inner nonsense. I knew they were conjugates. I'm going to use that to my advantage. So, what is my numerator going to become? Jake. What would you change about my numerator first? There's a couple options. Jake, anything you can do to my numerator? Right. He's combined, so you did two things really. He combined those. He said 60 plus 90i minus 30. Do we all follow that? And then you can combine the 60 minus 30 into 30 plus the 90i over. And Isaiah, how about the denominator? Right, but so it turns into 36 plus 36, right? 72. 72. I knew you knew what you were doing. And then the I part is all taken care of. We just have a common factor of, what's the greatest common factor of all of those numbers? It's actually 6, right? They're all divisible by 2 and 3, so they're all divisible by 6. So 5 plus, is it 15? Over 12. 5 plus 15i over 12. Okay, the exercise on the bottom. We didn't talk about this yesterday, but I know that you've dealt with it in the past. we have our parent graph of x squared. Is everyone on board with that? They're asking us to sketch x squared plus 1. What's the shift there? Up 1. Now that we moved it up 1, we have no x-intercepts, right? Does everyone agree? If you have no x-intercepts, you have no roots, you have no zeros. When you solve the quadratic down here, x squared plus 1 equals 0, you're not going to have any solutions. Or are you? Before yesterday, you would have just written no solutions, right? Subtract 1 from both sides. You get x squared equals negative 1. Yesterday, you would have square rooted both sides and you would have said, oh, no solutions. And it's true, you have no real solutions. But we now know that we have two imaginary solutions, plus or minus I. So we have no real roots, but we do have imaginary roots. We have no real zeros, but we have imaginary zeros. I don't know if anyone has ever said imaginary x-intercept, so I'm going to stay away from that. You still truly have no x-intercepts, but you would still say you do have roots and you do have zeros. They're just imaginary. Okay? So when you solve quadratics now, whether it's, well, it won't be by factoring anymore if they're imaginary, you would just go through the quadratic formula and you will simplify accordingly and you will give your imaginary answers. Okay? And so that's pretty much what all of the backside is. You'll have plenty to do your homework with. There's not much new today, just a lot of practice with the quadratic formula. So on your homework, a lot of quadratic formula. Just simplify your square roots of negatives using i's.